Good afternoon and welcome everyone. My name is Vinayak, Managing Service Offers, and we have a very interesting session. I'm sure partial discharge is something probably some of you have heard about, some of you have not heard about it, some of you know as internal arcs, have seen some failures. I'll start, just a bit of a warning, it could be a bit of a noisy start just to wake you up. But many of you probably would have experienced it or may have seen it in videos. But this is something which happens in our electrical systems. Sorry for the noise, but this is something which is happening in many of our electrical systems, and it can be very, very catastrophic. You know, the results can be something like this. You have a lot of equipment damages which can happen. More than that, there is a risk to the human lives and safety issues which comes in. And these are internal arcs. I'm sure some of you probably would have seen it. I have seen it myself, and it can be really, really dangerous and really scary. These are nothing but coming out of results of partial discharges which have not been monitored and have worsened over a period of time. So what are partial discharges? So partial discharges basically, one fact, 25% of the failures in medium voltage equipment happen due to these partial discharges. And it increases if you have dust, smoke, smoky environment in this. And it can happen from day one. The biggest thing is many people feel that, okay, it's an aging issue, etc. But this can happen from the day one the installation is happening. So let's go into a bit of basics on what partial discharge is. So these are nothing but local arcs. You know, you don't even see them many times. You can hear them. Many times they are very invisible. You don't know what's happening inside the equipment. I'll give you a small example. Imagine a water pipeline which has having water flowing through at a very high pressure, and there is a micro leakages or one micro leakage which is there. Obviously, if there is a small leakage, water will start piercing through, and over a period of time, and it will not be over a period of weeks, months, years, when this crack or leakages can become into cracks, and these cracks can cause full failure, and there will be a outflow of water, and it will go unobserved, and many times you cannot mitigate it if it goes unnoticed. Same way, partial discharges are small, insulation breakdowns which happen because of various reasons. We will talk about it, and can cause catastrophic failures, which we have seen earlier in our electrical systems. Typically, in any electrical system, you can have a partial discharge. But the effect, as I said, happens as we go on the higher voltages. That means 3.3 kV and above, you can have these issues coming up very, very strongly. As the voltage increases, the effects can be catastrophic. Maybe in 415 volts, it is not so much because the pressure is much lesser. So typically, it can happen in indoor switchgears, insulators, cable boxes, cable terminations, transformers. Rather, every electrical equipment at 3.3 kV and above systems have a risk of partial discharge. And what are the reasons why it can come in? Very basic is surface contamination. It could be dusty environment, no real maintenance, lack of cleaning, workmanship, specifically poor installation. In fact, poor installation is one of the major reasons of partial discharge. And you've heard about cable termination failures in systems, and many times during installation, if the termination of cable is not proper, you could have these issues coming from day one. And that's why we recommend that this is something which we should be monitored very closely. There could be manufacturing defects. Obviously, with very strong standards now from IEEE, and even the Australian standards are very strong on this, the risk is much lesser, but yes, it can happen. There could be wrong usage when you're applying the equipment wrongly, in a different application. Moisture ingress, again a reason because of environmental conditions, pollution, or there is any mechanical damage which happens during the installation or during service, or of course for aging, because aging can also create, because of the electrical stresses, etc., which is happening, the systems can go down. And of course, you can have issues like these coming in insulators, which can come in. And that's why monitoring of partial discharge becomes very, very critical. So what happens is, of course, we have heard about the failures, but partial discharge activity is a sign of aging, and it degrades the installation as it goes on. So it's something which is, if it doesn't go monitored, the insulation can degrade very, very, gradually and cause. So it's important to assess the risk which our systems have. It could be through periodic checking or through continuous monitoring. You can have these checks to avoid these issues coming in. And there could be various type of partial discharges. And this is where the monitoring becomes very, very critical, because not all partial discharges can be detected very easily. And different types have different types of effects and the risk on the systems. So one very basic type of discharge, which probably we have seen in high voltage or outdoor substations, is the corona discharge. You would have seen the blue light, the arcs probably coming in outdoor substations when a switching happens. This is basically happens in air or in the insulation medium. It could be in gases when you have a GIS. And the reasons could be basically coming in from, the causes could be condensation, improper environment. It could be some materials which are floating in the air. And how you can mitigate is you can probably work on the ventilation, you can work on the temperature management, etc. of the systems. And many times the sign of a partial discharge is the acoustic, the sound. If you see an electrical system, you would have observed in the video there is a hissing sound which was coming in. Okay? So that sound also, if you could hear that sound, you could see that something is going wrong, probably. And sometimes it's at a consistent level, and it can increase gradually if the insulation is weakening. Of course, with the sound, you have radio waves, and also if there is an arc which is developing, you have light, and you have ozone gas which gets created because the air is getting ionized. And of course, there are small micro transient voltages which are getting discovered. So corona discharge is something which is quite common. It can be dangerous, but of course, it's a phenomena which can be controlled in a way because it's visible. Then we have the surface discharges which happen over the insulators. If there is any, carbonization or dust, which could come in because of aging or normal operations, you can have this issue. And of course, the reason could be pollution, environment could be a reason, or installation design issues which could come in. And of course, cleaning is very critical. So regular maintenance requires cleaning, and basically other option is if it's not properly managed, the tracking, you can see the insulation, so you can see the tracks getting developed. They damage the insulator and you only have to replace the part. If you don't replace it, it can lead to a failure. And again, you have sound which comes out. You have radio waves, you have gases, again, because the air is getting ionized. Again, this is something which is still manageable because it's visible. The third and the most dangerous type of discharges which happen is the internal ones, which could be because of internal issues which is happening inside the insulation systems. It could be micro holes, some cracks, etc., which come in, and they often do not get detected. And it could be because of incorrect installation, some issues in manufacturing or design, improper cable terminations, etc. And the only solution here is you need to replace the part. If the partial discharge is an internal type, there is no solution. You cannot mitigate this without replacing the part. And it's very, very dangerous because you cannot hear it, you cannot see it, so you do not know whether it's happening or not. And the only way to measure it is through radio waves or through transient voltage measurement, which is often very difficult. So you need specific sensors to measure it. And this is where the whole monitoring technology, etc., are coming in. Now, how do we measure partial discharge? Because of course, you've understood the issues which are happening, what are the different type of discharges, but how do we mitigate it? Through measurement and of course, monitoring technologies. So, of course, one very basic is through monitoring of gases, chemicals, of course, ozone, but it's not very good because if the gas is there, that means automatically the discharge has already happened, the air is already ionized. So not the best of ways to measure partial discharge because you cannot mitigate the issue. Second is optically. Visually, you can have a camera to observe it. Again, not very good because it's only detecting only one type or two types of discharges, which is not very, and already the discharge has happened. The damage is already done. Third is sound measurement. It is used sometimes, again, limited application, not very accurate. You are not able to measure the exact level of partial discharge in picocoulombs. The third is through electromagnetic high-frequency measurement of voltages. Again, this is something which is in use. It is pretty good, but again having issues in terms of sensitivity and to detect where the fault location is coming in. And of course, in some of us applications, we use this technology also. The last is probably the most accurate is through electrical coupling, where we have measurement through capacitive couplers. Basically, we measure the capacitance in the switch gears to see if there is any partial discharge which is getting developed. And this is very good, but of course there is it's an invasive technology. That means you need to modify the design of the switch gear to have a specific insulator to measure it. And of course, we have, and there are, a lot of vendors who are now into these technologies, but this comes with high accuracy. And it is often something which is recommended by us. And this is where, as Schneider, as an OEM, we have developed these solutions for monitoring. And our approach in our new switch gears, which we call as active plus switch gears, which are coming with these sensors by default. We have these insulators designed by default. So if you buy a new AIS switchgear from Schneider, this is coming in by default, and of course, come with the monitoring plans, etc. So we have a capacitive coupler, which measures the partial discharge in picocoulombs, highly accurate, and we have a 24/7 monitoring system. So it is measuring the whole partial discharge, and plus we have our diagnostic. That means the analytics which are running, which are able to detect if there is an issue which is developing inside the system. And we are able to kind of have a thing, and we can give advisory to you to do a detailed check. Suppose if there is a issue which is coming in the system, we're able to do a detailed check through detailed diagnostic systems, etc. Can get in front of the panel and have a check in a detailed way during our maintenance calls. So this is our approach. Now, what's the architecture? How do we install the sensors? How does it look like? So this is a typical MV switchgear panel. If you see, we install, there is a partial discharge which gets developed, and we have a specific insulator. If I can, yeah. So we install a specific sensor here. This detects the discharge, and we have a sensor which, we have the coupler here, and we have the sensor which measures the partial discharges. We call it as PD100. And we are communicating it to a system, a gateway, and it goes to our cloud processing program where we have all the analytics to analyze what is the kind of discharge and what could be the issue which is coming in. So this is the architecture which is there, and again, available from day one. Now, the whole idea is, why do we need to have continuous monitoring? And why do we need experts to do the processing? Again, partial discharges are quite complicated. You could have different kind of curves. It could also, you could also have external mediums. Suppose you're doing a noise measurement. You could have a motor running in your system, or you could have a generator running in your system, and it could disturb the signal. So you need an expert data processing and an expert to analyze the signals and tell you what's the noise and what's the actual issue which is happening. And this is where our overall EcoCare program comes in, where we are having our systems installed in the new switch gears. We have 24/7 monitoring with our cloud systems. We have the system connected from cloud right from the factory. That means once it's installed, it is plug and play, and it directly gets connected. And we have our experts through our EcoCare service plans who are monitoring the systems and advising you on what's the issue, telling you what's there, and they're like the experts on call who could tell you what's going wrong in the system. And of course, if you want to know more, you could go to our booth in the infrastructure segment where we have the demos. We can actually show you how the whole monitoring is happening, how the cloud program is running, what's happening inside the systems, and we can take it forward. So I will pause here. Any questions? Anyone would like to know more about it? I think we can close the session, and feel free to go to the hub for the demos. I'm there. If there's any further questions, happy to discuss it, take it offline. Thank you.